Welcome all. Now I am going to discuss question number 33 from the GATE 2021 paper Electrical Engineering. The question is, in a single phase transformer, the total iron loss is 2500 watts at nominal voltage of 440 volts and frequency 50 Hz. The total iron loss is 850 watts at 220 volts and 25 Hz. Then, at nominal voltage and frequency, the hysteresis loss and eddy current loss respectively are. These are the given options. To know the concept and detailed modeling of hysteresis and eddy current losses in a transformer, audience can go through the given NPTEL video link. Let us discuss some useful information to solve the problem. EMF induced in the transformer is given by this equation. E is equal to 4.44 Bmax into A into F into N, where Bmax is the maximum flux density and it is measured in Weber per meter square, and A is the area of the transformer core, F is the frequency of the supply, and N1 is the number of the turns. And the hysteresis loss in a transformer is given by WH is equal to KH into F into Bmax to the power 1.6, where KH is the hysteresis constant, F is the frequency of the supply, B is the maximum flux density and it is measured in Weber per meter square. And the eddy current losses in a transformer is given by WE is equal to KE into B max square F square T square into V square. Here KE is the eddy current loss constant, B max is the maximum flux density and it is measured in Weber per meter square, F is the frequency of the supply, T is the thickness of the core and V is the volume of the core. Using this information, let us solve the problem. So, given data. What it is given? Given is total iron loss. Total iron loss means it is hysteresis plus eddy current loss. That is equal to 2500 watts at voltage V is equal to 440 volts and frequency is equal to 50 Hz. Frequency is 50 Hz. Also, it is given that again total iron loss is 850 watts at voltage V is equal to 220 volts and frequency is equal to 25 Hz. So, we need to find out the iron loss at nominal voltage. Nominal voltage, that is V equal to 220 volts and F is equal to 50 Hz. Also, as we have discussed previously, EMF induced in the transformer is given by E is equal to 4.44 into B max into A into T1 into F. So, if we divide both sides with frequency, that is E by F is equal to 4.44 into B max into A into T1. We know that for a particular design, area of the core of the transformer is constant. This is constant and the number of turns in the transformer is also constant after particular design of a transformer. So, if these two are constant, we know that for a particular material, Bmax is also constant. Bmax is also constant means in a transformer E by F ratio is constant. E by F ratio is constant. So using this information, let us solve the problem. And we also know that hysteresis loss is given by Kh into F into Bmax to the power of 1.6. Bmax to the power of 1.6. We know that Bmax is constant. So, Bmax is constant, right? So, Wh is equal to some constant Kh into Bmax is constant, right? Only frequency will vary. So, we will write this one as A. A into F. Similarly, eddy current losses is given by Ke into Bmax square into F square T square into V square. So for a particular design, these all terms are constant except the frequency term. So We is equal to that constant, we will write it as V into F square. So we can write the iron losses in the transformer is equal to A into F plus V into F square. In the question we have know that 440 by 50 Hz is equal to 220 by 25 Hz. P by F ratio is constant from the supply. So, iron loss we got like this. Wi is equal to AF plus BF square. So, let us solve the problem using the above information. So, Wi, first case, 2500 watts at frequency is equal to 50 Hz. And in the second case, 850 watts at frequency is equal to 25 Hz. So, we can write 2500 is equal to A into F 50 plus B into 50 square. Just now we found this relation. Similarly, in the second case iron loss is 850. So 850 is equal to A into 25. Frequency is 25 plus B into square of the frequency. This is equation 1. This is equation 2. If we solve these two equations, we get A is equal to 18 and B is equal to 0.64. So in the question, it is asked that to find out the iron loss at nominal voltage, that is 220 volts, and the frequency is 50. Nominal frequency is 50 Hz. So A into F plus B into F square. A is how much? 18. Just now we found out. Nominal frequency is 50 plus B is how much? 0.64 into square of the frequency, that is 50 square. This is the hysteresis loss component This is the eddy current loss component. So, if we simplify, hysteresis loss as 900 watts and the eddy current loss is 1600 watts. The hysteresis loss and the eddy current losses are 900 watts and 1600 watts. Thank you.